Friends, welcome to my YouTube channel. We are going to do the next questions from ADF track and drift related questions from RK Bali. I hope you have understood the questions that I have solved so far, and I hope that you get these questions also. So all the best. Let's start. Question 12. Aircraft flies a constant heading with 5 degrees starboard drift, making a track made good of 5 nautical miles to the left of the center line. What will be the relative bearing, that is the ADF reading, and NDB is 30 nautical mile ahead of the center line. So let's start doing this. We have not been given a heading. So let's consider aircraft heading is 090. Okay. Drift is how much? It is 5 degrees starboard drift. For a starboard drift, a heading is less than track. So if heading is 090, track will be more than heading by the amount of drift, which is 5 degree. So track will be 095 degree. Okay, so track will be 095 degree. Now you are making a track made good 5 nautical miles to the left. So let's draw this. So there is an NDB station which is in front of you. The track, okay, initially the track uh, the track to the station that we have found, the initial track to the station is how much? Initial track to the station is 095. So I am writing here magnetic bearing to the station. Initial magnetic bearing to the station is 095 degree. Now there is another information given to you, that is you are 5 nautical miles to the left of the track. You are 5 nautical miles to the left of the track. The remaining distance towards the station is how many miles? 30 miles. Now you have to, so your aircraft is somewhere here. Aircraft is somewhere 5 nautical miles to the left of the track. Okay. And now you have to find a new track towards the station. So this was initial. Okay. You were supposed to be on this track and then go towards the NDB station. But you have found yourself 5 nautical miles to the left of that track. And therefore, you have to find the new track to the station. You have to find a new track to the station. Okay, and then relative bearing. So let's find that out. So this will be called final magnetic bearing to the station or final track towards the station. Okay, so from here this will be a new track. So let's calculate using this 1 in 60 rule the angle over here, this angle. So that angle will be a closing angle, which will be equal to distance of track by distance gone into 60. So 5 divided by 30 into 60 is 10 degree. So angle is 10 degree. So if this is 10 degree, I will also write 10 degree here. Alternate angles are equal. That's why if this is 10 degree, this will also be equal to 10 degree. Okay. Now, of your aircraft is how much? We have considered it to be 090 degree. So the new track, I am writing here, final magnetic bearing to the station will be equal to your heading plus you will have to turn right hand side, you will have to turn another right hand side 10 degree So which will be 0,905 plus 10, which is equal to 105 degree. So final magnetic bearing to the station or track towards the station is 105 degree. Initial was 0,905, the new one is 105 degree. Now, what is ADF? So what is ADF? ADF means what? ADF is nothing but your relative bearing, and relative bearing is magnetic bearing to the station minus magnetic heading. So magnetic bearing to the station is how much? The final one, 105. 105. What is magnetic heading? Magnetic heading is 0,9 0. So 105 minus 0,9 0 is what difference? It is 0,15 degree. So relative bearing is 0,15 degree, meaning as you can see diagrammatically also you can see NDB is to the right of aircraft, and we have done this so many times. Diagrammatically, if this is my NDB and if this is the track is what, let's say we have found out here was track towards the station was how much? 105 degree. And what is the aircraft heading? Aircraft heading is 0,9 degree. So 0,9 degree is somewhat this, right? Heading is 0,9. Now what is relative bearing? Relative bearing is the angular difference between heading of aircraft and track towards the station, measured from heading. So starting from heading towards the track, this angle will be how much? So this is 105, track towards the station, heading is 090. The difference between them is 15 degree. So relative bearing is 15 degree, 015 degree. So NDB is to the right hand side of longitudinal axis of this aircraft at 015 degrees. Let's go to next question. Compass heading is 270, deviation is 2 degree west. So compass, deviation, magnetic variation and true. So compass heading is 270, deviation is 2 west. Deviation west, compass is best. That means compass is more than magnetic. So magnetic will be less than compass. By what value? 2 degrees. So magnetic will be 268. Variation is 30 east. If variation is east, magnetic is least, meaning true will be more than magnetic and magnetic will be less than true. So true direction will be 268 plus 30, which is 298. Okay. We have been asked to find QDR. QDR is magnetic bearing from the station. Okay. So what is compass heading was 270. Magnetic heading is 268. Magnetic heading is 268. Relative bearing is given 316. Before finding QDR, let's find QDM. QDM is how much? How much is magnetic heading plus relative bearing? 268 plus 316. So relative QDM is 224 degrees. QDR will be the reciprocal of that, which is 044 degree. QDR will be 044 degrees. So option B is the correct option. Okay. Let's go to next question. The inbound track to NDB is 075. Before that, if you want to represent this diagrammatically, it will be like how this is your NDB. QDR is 044. QDM is 224. Your aircraft is on a heading of 268 and relative bearing of 316. That means it is approaching the station. Relative bearing is somewhere around 360. That means you are approaching the station. So let's draw this 268 is your magnetic heading and relative bearing is 316. QDR is 044. Okay, towards the station, and QDR is 044. So your aircraft is somewhere here on a heading of 268. So 268 will be this. So 224 is this way. 268 will be more than 224. So somewhere in this direction, close to 270. So this is your aircraft heading, and relative bearing starts from heading, which is 268, from 268 to your QDM, which is 224. So the total will be 60 minus this angle, which is 268 minus 46. So it's 360 minus 44 is 6651. 316. Okay. So relative bearing is 316. This value is 316 relative bearing, which is given in the question. Next, inbound track towards NDB is 075. Okay. So QDM is 075. QDR will be 75 plus 180, which is 255. Variation is 10° west. Okay. So this track, correction, my fault, track is true. So let's convert this first. QUJ given to you is 075. So QDM will be how much? QTE will be 255. So QDR will be how much? So variation is 10° west. If variation is west, magnetic is best. Okay. Inbound track is QUJ in terms of true. So variation is west, magnetic will be west, best. So QDM will be 075 plus 10, which is 085. 085. And QDR will be 265. Fine. Next. Drift is 7° right. The relative bearing that you will have to maintain to reach NDB will be how much? Will be how much? So let's draw this NDB. So QDM 085, QDR 265. You have to approach the station, right? Drift is 7° right. If drift is 7°, if drift is starboard 7°, your heading will be less than track. Okay. So what is track? You're going inbound. So inbound track is what? 085. Inbound track is 085. So heading will be how much? It less than track. 85 minus 7, which is 078. Heading is 078. So let's draw this. So you are currently on 265, track 265, heading towards NDB, which is 085 track, and heading is 078. So 078 is somewhat less than 085. So aircraft will point a little bit towards left hand side. So heading is what? 078. Now we have to find relative bearing. What is relative bearing? The angle between QDM and your heading. Okay. So that angle will be this. Clockwise starting from the heading. So what is the difference between these two angles? 85 minus 78 is what? It is 7 degrees. It is 7 degrees. Okay. So relative bearing that you will have to maintain is 007 relative. Okay. So this is how you do the sum. QUJ was given to you through bearing towards the station. From that you obtain true bearing from the station. Using variation you obtain the corresponding magnetic directions. Plot the diagram. Now heading was not given to you. Heading was 078, which is less than 085. How? Its starboard drift heading is less than track. Okay, then plot heading. Now relative bearing, you know angular difference between your heading and track. Now depends. If you're going towards the station, it is inbound track. If you go away from the station, it is outbound track. Next, aircraft is homing to a station, maintains a relative bearing of 0 degree, right? So if this is your station, NDB station, if you are okay tracking towards it, okay, you're tracking towards it. Let's say I'll erase this. This is your NDB station. You're tracking towards it. So that means if your relative bearing is 0, that means your track towards the station is equal to the heading of aircraft. There is no angular difference between them. In other words, you are flying in nil wind conditions. You don't need to apply any crosswind technique. So very easy flying. Okay, relative bearing is 0 degree. That means NDB station is directly in front of you or ahead of you. Next, if the magnetic heading decreases, the aircraft is experiencing what kind of drift? Okay. Now this is condition number 1. In where there are no wind conditions, the heading of aircraft is directly pointing towards NDB. In other case, they are saying this is your NDB station and you are still tracking towards the NDB station, but the heading of aircraft has decreased, meaning now aircraft is heading to its left hand side. Heading decreases means heading turns left hand side. Okay, so now this is your new heading. This is your track. Over your heading and track were equal. So now if heading has decreased, or if heading has, if you have turned your aircraft heading to the left hand side, so that means what kind of drift you are getting? You will be getting a starboard drift. A starboard drift. Why starboard drift? How? Like I have always repeated so many times, in case of starboard drift, your heading is less than track. So this is how you come to know that you are experiencing a starboard drift, and in order to prevent that, you have applied a wind correction to the left hand side. So if heading is less than track, it will be a starboard drift. Whenever you turn left, angles decrease. Okay. So the correct answer will be what kind of drift? It will be a starboard drift. It will be a starboard or right hand side drift. Question 16. Aircraft is flying at 9,000 feet towards a station and ground is at 1,600 feet above sea level. So this is a direct formula. That is distance to the VOR station is 1.23. Some cases 1.25, not much difference. H1 plus H2, where H1 and H2 stand for the height of aircraft and VOR station respectively. So 1.23 square root of 9,000 plus square root of 600, 1,600, 1.23. So 95 root of 600, 1640 into 135 is 166 nautical miles. So option A is the closest option. So that is how you do it. Formula based question, very scoring, frequently asked question in CPL, ATPL, also airline exams. So with this, we come to the end of this lecture. So I hope you have understood this lecture. You are comfortable solving track and drift questions, formula based questions. You are able to visualize the diagram of every question, that is must, and that testifies your conceptual understanding also. So if you have liked this lecture, hit the like button, let me know that, and subscribe to this channel and share this video with everyone. Thank you for your time. All the best.